So letter E talks about concavity. Okay, concavity. Well, we know concavity is based on the second derivative test. And the definition is right here. When the second derivative is positive, the graph of f is concave up. When the second derivative is negative, the graph is concave down. And when the second derivative is 0, the graph it's called an inflection point. All right, it's called an inflection point. It has no concavity or on that interval. Okay. So problem is though, we only have this. Okay, let me erase some of this stuff so we can. Okay. And this is a graph of f prime. So remind me again, f is concave up when what? When the second derivative, f double prime, is positive, and f is concave down when, there you go, f double prime is negative. Okay. Well, the graph we're looking at is not f double prime, or it's not f, it's f prime. So what do we need to do to figure out f double prime? Information about f double prime. What do we look at of this graph? What do we need to look at from this graph to figure out information about f double prime? The slopes. We need to look only at the slopes, right? We need to look only at the slopes. If we want information about f double prime, we need to look at slopes. Slopes of this graph. Because slopes are derivatives. And the derivative of the first derivative is the second derivative. Okay? Okay. So we need to look where slopes are positive for concave up. Okay. What does that mean if I say slopes are positive? What's another way of saying that? Using this kind of terminology. If slope is positive, what's another way of saying it's increasing? Yeah, increasing. So that's what we're looking for. We're only looking for where it's increasing, where this graph is going uphill. Okay? That's what we're looking for. So let's see. It looks like it's starting going uphill there, keeps going uphill until about there. Looks like from there to there, it's going uphill. And then at the start, around here and there, looks like it's going downhill. So where it's green is where it's going to be concave down because the slope is negative, right? When it's purple, it's going to be where it's concave up because the slope is positive. Okay, so let's go write that down. That's not going to be our justification though. Okay, that's just going to help us find the answer. Okay, so let's go right. Concave up. Concave up looks like it's from -2 to 4. Okay, so let's go write that down. Concave up from -2 to 4. Let's concave down. Let's write concave down. Concave down has 2 intervals. Looks like it starts at -6 to -2, and then 4 to 6. Four to 6. Okay. Because. Okay, so now this is where you go to your sentence frame. We just said it about 5 minutes ago, not even 5 minutes ago. Concave up, justification for concave up. When does that happen? When Okay, that's what we're going to write up here. Concave up because f double prime is greater than 0 or is positive. You can say f double prime is positive, same thing. And then we said concave down when, there you go, that's our justification. Okay, that's our justification. Okay. Now the question says, if f of negative 2 is 4, find the equation of the tangent line to f of x at x equals negative 2. Okay. So we need to find the equation of the tangent line. So anytime we need to find the equation of the tangent line, we need to use point slope form, right? Point slope form. So y minus y1 equals mx minus x1, right? And we need to fill in the green guys. The green guys are the ones we need to fill in. Okay. Which one is given? Two of them are given. Which two are given? Say it again. Okay, good. I'm given y. So let's start with x. What is x1 going to be? Negative 2, because it says right there x equals negative 2. Good. So negative 2, which means it would be positive 2 on the inside. Okay. Now let's go to y1. What would y1 be? Not negative 2. 4, yeah. Y1 would be 4 because it says at the very beginning. It says at the very beginning here that f of negative 2 equals 4. That's a point. When x is negative 2, y is going to be 4. That's a point on the original graph. And that's what we need, a point on the original graph, because they want us to find the tangent of f, the line tangent to f. Okay, now we need the slope. So I need the slope. I need the slope at negative 2. So how do I find the slope of f at negative 2? Give you a hint, you're going to use the graph. What does the graph represent? F prime. And what is f prime again? The slopes of f, right? This is all slopes of f. This is a graph of slopes of f. Isn't that what we're finding? Try to find? We're trying to find, right? We're trying to find a slope of f, right? The only question is, where am I trying to find the slope of f? At negative 2. So let's go to negative 2. Negative 2 is here, right there. That point right there is negative 2, negative 2. Well, negative 2 is x. What does y represent? One more time. This graph, what does this graph represent? The slopes of, so what does y represent? The slope at negative 2, right? The slope at negative 2 happens to be negative 2. It's just a coincidence. The slope at negative 2 is also negative 2. That's our slope. So we go down here and we change this to negative 2. You're done. Doesn't say it needs to be in a specific form because it's a free response question. It doesn't say anything, so we leave it in point slope. You can change it to one of the other 2 forms, but it doesn't say you need to, so I'm done. Okay? Those are the questions they will ask you. They will ask you questions about critical values, increasing, decreasing, relative max, relative min, points of inflection, concave up, concave down. And almost every single time, they will give you a graph of f, or sorry, f prime. They won't give you the graph of f. They won't give you double prime. They'll give you f prime. Okay? Okay, so what are we looking for? So the next thing is notes to ourself. What are we looking for? Okay, so let's go down here. Guidelines. Guidelines are little notes to yourself. What are you looking for? What are we looking for here? Because you're going to do one on your own. You're going to do. I'm going to give you a problem. You're going to do the same questions, but on a different graph, a little bit. So this will help you. What are you looking for? So if you're looking for a critical value for f, and they give you a graph of f prime, what are we looking for? Not the justification. Justification is different. What are we looking for on this graph? That was the very first question we did, right? What were we looking for to give our answer to A? Mhm. There you go. Where did it cross the x-axis? Points at where it crossed the x-axis. So let's write that down. Okay, let's write that down. So crosses where the graph, where f prime crosses. Here's a question. What if it just touches the graph? Like, what if it just, so like, what if I have a graph? Let's say this graph, let me use a different color. Let's say we did this, right? It went down here, but then it kind of bounced off. Would -4 still be a critical value? It would be. It would be. So bounces is okay, crosses is okay, just touches. So let's make sure we put that. Crosses or touches the x-axis. Okay. Oh, sorry. And then or has an undefined point. We didn't see this, but if f prime has something undefined, that means there was a critical point. Okay, so that's what we're looking for. Okay, relative maximum, relative minimum when we're looking at this graph. So when I'm looking at this graph here, what told me there was a relative maximum or a relative minimum? What told me? Exactly, when it crosses the x-axis from positive to negative. When it crosses the x-axis from positive y values to negative y values. Okay, so let's write that down. Where f prime crosses the x-axis from positive y values to negative y values. Good. That's good. So not only does it have to cross, but it has to cross from positive y values to negative y values. Wherever it crosses, that's where there's going to be a relative maximum minimum. Or sorry, maximum. Minimum is just the opposite. Minimum is where f prime crosses the x-axis from negative to positive. Okay, so it's going to be almost word for word, just a couple words swapped. Where f prime crosses the x-axis from negative y values to positive y values. So this one where it comes up. Comes from the bottom, comes up and crosses. Okay, good. Okay. Now, when is it increasing? When is the function increasing on our graph? There you go. When f prime, when the graph, or when f prime, either one, is above the x-axis. In other words, positive y values. Positive y values. Okay. The converse, when is it negative? Or when is it decreasing? When f prime is below the x-axis. Negative y values. Okay. Good, good. So far, so good. Points of inflection now. So now we're moving to f double prime. When did we see points of inflection? This is the last thing we did yesterday. When did we see points of inflection on this guy? What were we looking for? Yes, that's exactly right. When f prime, when the slope of the graph changes signs, either from positive to negative or negative to positive. So when this guy, when its slope changes, decreasing, 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 increasing, when it changes signs. So when the slope of f prime changes signs. Let's put that. And I'll put down here. Positive to negative. Or negative to positive. Either one. Okay, where the slope changes signs. Good. Two more. Or actually three more, I think. Yep. Concave up, concave down. The first one we did today. Where did we look for concave up and concave down on our graph? Where the graph was increasing. Another way of saying increasing is where the slope was positive. Where f prime has a positive slope. And the other one would be the opposite. Where f prime has a negative slope. Okay. And the last one, how did we know where to find the slope of the tangent line? The slope was -2 on the last one, right? The slope was -2 on the last problem we did, the one in red. And now, there we go. How did we know where to find that on the graph? There you go. The y value it was the y value of f prime at the same x value. So wherever they told you, or I should say the given, not the same, given x value. Given x value. So they said, here's the x value, tell me what the y value is at that point. So if I said, give me the slope of the tangent line for -4, x equals -4. You go to -4 and you find the y value. That's the slope. Okay? Okay, so now what I want you to do is I want you to use those on number 2, example number 2. I ask you the same questions, different graph this time. Okay, different graph this time. Try F. Don't worry about F. I want you to try F, but if you can't get it, it's okay. But try. I think you can. It's a little different, but you. I think you can do it. Focus on A through E. Okay. Remember to include justification. Also include justification. Okay. Okay. So let's talk about this. So they give us a graph of F prime, just like we did the first one. It says it's closed from 0 to 8, so it only goes from 0 to 8, and it's got horizontal tangents at 2, 4.75, and 6. So this graph has horizontal tangents. Okay, so it's got 0 slopes. The slope of the tangent line of this graph is 0 at 2, 4.5, 4.75, and 6. Okay. All right. So the first one, critical values. Critical values. Well, we go to our guidelines and we say critical values are located when it crosses or touches the x-axis or has an undefined point. Okay. So there are 3 spots when it crosses or touches the x-axis, right? Where is that?
X equals 1, x equals 4, and x equals 6.
4 and x equals 6. Good. That's the answer. Now for our justification, we go to the board and we say that it's critical values because f prime is 0. We didn't have any undefined points on this graph. There are no undefined. From dot to dot, it's undefined. So we say because f prime of x equals 0. That's our justification. Okay. Okay. Intervals of increasing and decreasing. Intervals of increasing and decreasing. Well, let's go to our guidelines. We said from the graph prior that it's increasing. The graph is increasing when f prime is above the x-axis. And it's decreasing when f prime is below the x-axis. Okay. So I'm going to highlight those. So above the x-axis, I'm going to say right there, and right there. Below the x-axis is everything else. Okay. So increasing is positive y values. Positive y values. Okay. So increasing, let's see. Increasing is going to be from, let's see, increasing 0 to 1, or also 4 to 6, and from 6 to 8. Because f prime is positive there. F prime is positive. F prime or f prime of x. Okay. Decreasing. Decreasing is from 1 to 4. From 1 to 4. That's the only spot it's decreasing. And that is because f prime is negative. Okay. All right, let me erase my marks now. Let's go to the next question. Maximum, minimum. Maximum, minimum. So we go to our guidelines. We said the maximum occurs when f prime crosses the x-axis, but it has to cross from positive to negative. From positive to negative. Okay, so let's go see that. It crosses from positive to negative here, and that's it. It crosses from positive to negative at one spot. Okay, so we're going to say relative max at x equals 1 because f prime changes from positive to negative. Okay, f prime changes from positive to negative. Okay. Now relative min. Relative minimum. Well, we said relative minimum occurs when f prime crosses the x-axis from the negative to the positive. Where does it come up and cross? One spot. Positive 4. Because f prime changes from negative to positive. Okay. It touches at 6. So 6. So here at 6, right? It touches. It's considered a point of. It's considered a critical value, right? But it's not a maximum or minimum. It's not considered a maximum or minimum because it goes positive and then keeps positive. It doesn't cross over the negative. So 6 is nothing. 6 is neither. It's a critical value, but it's not a relative maximum or minimum. Okay. Points of inflection. Points of inflection now. Points of inflection. Well, let's see what our guidelines say about points of inflection. It says when the slope changes signs. When the slope of f prime. So when the slope of these guys here changes signs. So let's see. What does that mean? Well, right now my slope is negative because I'm decreasing, right? But here it changes, right? It changes at 2. Changes direction. And then it also changes direction at right about there. And then it changes direction one more time. Right? Those are all horizontal tangent lines, and they told us, right? They told us at the very beginning, 2, 4.75, and 6 were all horizontal tangent lines. That tells us that they're all going to be points of inflection. Okay? So we have points of inflection at 2. X equals 4.75. X equals 6. Because f prime is 0. Not undefined. This one's not undefined, so we don't have to say it. Okay. F prime equals 0. Okay. Last one for this. Concave up, concave down. Concave up, concave down. Okay. Our guidelines say concave up when, I skipped it. There we go. When f prime has a positive slope, increasing. When it's increasing. When f prime is increasing, it's going to be concave up. Okay. So let's see here. Increasing here and increasing here. decreasing here, decreasing there. Okay. So concave up. We would say concave up from, that's the green stuff, increasing from 2 to what value is that? What x value is that? 4.75, right? 4.75 right here. So 2 to 4.75. And then from 6 to 8. And then we would say because f double prime is positive. That's where f double prime is positive. Okay. Concave down. That's the purple stuff. So from 0 to 2 and 4.75 to 6. From 0 to 2 and 4.75 to 6. Because f double prime is negative. Done. Okay. How much more confident are you in your answers with the guidelines? Super, super helpful, right? The guidelines are super helpful because they tell you exactly where to look to find the answer. And then these justifications give you your second part. They give you where do you go look? Okay, where do you go look? Or sorry, what's your justifying your answer? How do you back up your answer? Okay. Okay, so last one. So then they introduce a new function. They say g of x. G of x is kind of a composition of f. It's x squared minus f of x. Okay, that's the equation. Okay, so let me rewrite it. G of x equals x squared minus f of x. I already know f of x, right? It's the graph. Okay, then they want me to do is find g prime of 2. G prime means derivative. So let me find the derivative. What's the derivative of x squared? Okay. What's the derivative of f prime of f? F prime, yeah. And then last step, plug in 2. Everywhere I see an x, I plug in a 2. 2 times 2 is 4. That guy there. F prime of 2. What is that saying? F prime of 2 is asking for the slope of the tangent line at 2. The slope of f. Where do I look? There you go. You look at the y value of this guy at 2. Let's see. The y value at 2 is a negative 2 again, right? It's 2, negative 2. Just a coincidence it's negative 2. So the slope of the tangent line at 2 is negative 2. So this guy will equal negative 2. Subtract a negative, change the sign, and you get positive 6. Done. Okay, done. All right. Okay, so tomorrow what we're going to do is I'm going to give you some practice. I'm going to give you some practice on your own where you're doing stuff like this. I'm going to give you a graph, and I'm going to ask you these kinds of questions. Find the increasing, decreasing, relative max, relative min, all of this good stuff, just like you just did. Okay? So tomorrow we're going to do some practice on your own. Now, make sure you already have your guidelines written down, right? Your guidelines are this is very important. This should be sacred to you because this is going to help you with the graph, right? That's the first thing. Second thing, make sure you have your justification somewhere in your notes. Okay, make sure you have those in your notes. Okay, because those are just as important. They don't help us with the answer, but they help us with the justification. Okay? All right. Okay.